Everyone, my name is Kavleen and I'm a sophomore in chemical engineering. Today we'll be discussing how we can use Laplace transform table to do the Laplace transformation. So the general form for Laplace transform is L, curly brackets, and whatever the function is given. And one of the properties for Laplace is linearity, which is we can distribute the Laplace transform into the given function. For example, if we look at our first problem, there are two different parts, so we can distribute it. So it would be L of t squared plus L of e raised to power t sine 2t. So going forward, we have to look at this table to do the Laplace transformation. If we look at our first part, which is t squared, this resembles our third point on the table, which is t raised to power n. So in this case, our n is 2. So it will be 2 factorial over s 2 plus 1. So 2 factorial s 2 plus 1 plus e raised to power t sine 2t. This resembles our this part, e raised to power at sine bt. So we have to use b over s minus a whole squared plus b squared. So in this particular case, we have a equal to 1 because our e raised to power is 1t, so our a is 1. And b is 2 because it's sine 2t, or b is 2. So we have to write b, which is 2 over s minus a is 1 whole squared plus 2 squared. So our final answer is 2 factorial is 2 over s raised to power 2 plus 1 is 3 plus 2 over s minus 1 whole squared plus 4. This is our final answer. Another problem using the Laplace transform is sine squared t. So in this case, we have to use trig identity, which is 1 minus cosine 2t over 2. So sine squared t can be written as 1 minus cosine 2t over 2. This is the trig identity. So we can take out the constant, which is 2. So it will be 1/2 Laplace of 1 minus cosine 2t. And here we can use the property we just learned, which is the linearity, where we can distribute the Laplace. So here it will be L of 1 minus L of cosine 2t. So looking at the table, we know that it's the first point, which is 1, which gives us 1 over s. So it will be 1/2 bracket 1 over s minus, and for cosine 2t, we are using cosine bt, which can be written as s over s squared plus b squared. So in this case, our b is 2 because it's cosine 2t. So it's s over s squared plus 2 squared. So we get 1/2 1 over s minus s over s squared plus 4. And we can further solve it to get a common denominator, which is s times s squared plus 4. And we get s squared plus 4 minus s squared, and this cancels out. So our answer is 1/2 times 4 over s times s squared plus 4, and this cancels out, and we're left with our final answer, which is 2 over s bracket s squared plus 4. So this is our final answer of Laplace transform. We can do another such example with Laplace transform, which is here. So again, we can use the distributive property, which is e raised to power negative t cosine 3t, and we can distribute the Laplace with the to the rest of the given equation. So plus of e raised to power 8t minus Laplace of 1. So looking at our table, we know that this is the last point on the table, which is e raised to power 8t cosine bt. So our transform will be s minus a over s minus a whole squared plus b squared. So in this case, our a is -1 and b is 3. B is whatever we have after cosine. A is whatever we have e raised to power. So here in this case, it's -1t, so it should be -1. So using Laplace, we have s minus a is -1 over s minus -1 whole squared plus b is 3 raised to power 2. So this is the first part, and then we can do the second part, which is e raised to power 8t. So looking at our table, we know that its second point e raised to power 80. In this case, our a is 8. So it should be 1 over s minus 8. So 1 over s minus 8. And then minus the plus of 1. And this is the first part. 1 is 1 over s. So it should be 1 over s. And we can further solve this part, which is s plus 1 over s plus 1 whole squared plus 9 plus 1 over s minus 8 minus 1 over s. So this is our final answer for this part. Moving forward, we can use this table to also do the inverse Laplace. So for inverse Laplace, this is our general form that we use. So here we'll be given the right hand side of the table, and we have to do the opposite. We have to figure out the left side, so kind of going backwards to solve the problem. So in our first problem, it's 2 over s cubed. So from s cubed, we can see that we don't have s cubed anywhere unless we add it. So it has to be n factorial over s n plus 1. So if we go backwards, it would be 2 factorial over s 2 plus 1, which will give us what we have right now, which is 2 over s raised to power 3. So we know that it has to be t raised to power n. So for this case, it's t raised to power n is 2. So it should be t squared. So this is how we go backwards. So let's do another problem with Laplace, inverse Laplace transform. So looking at this problem, we can tell from the table that it's so s plus 1. So we know that in the numerator there's s plus something. So looking at the right hand side of the table, we know that we don't do s plus anything until the last point, which is e raised to power 8t cosine bt. So we know that it has to be s minus a over s minus a whole squared plus b squared. So we have to go backwards from here. So it is s minus a. So we know that here instead of plus, we have to convert it into negative. So one way to do it is doing s minus 1 over in the bottom. We know that we have s minus a, so our a is -1. And so now the only thing we have to solve it solve for is b, so we don't know the b yet. So if we open the square of s plus 1, we'll get s squared plus s squared plus 1 plus 2s. So from here we know that, so in the problem we have 10. And here we have s squared and 2s, which is s squared here and 2s here. The only thing is we don't have 10 yet. We know that we have added 1 to whatever our b is. So our b has to be 9 in order to get 10 in the end, because when we do s minus 1 whole squared, we get s squared plus 1 plus 2s, which will give us s squared and 2s from the problem, and we have to add 9 into 1 to get 10. So our b has to be 3 squared, because in the formula it's b squared, so square root of 9 is 3, so that's how we'll get b out of it. So if we're looking at this equation, we know that our a is -1, our b is 3. So going back to our table, looking at e raised to power at cosine bt, so our solution would be e raised to power a is -1t, cosine b is 3t. So this will be our final answer for this problem. So here we have another problem where we can use Laplace to do the inverse transform. So if you're looking at the problem, we know that it has to be something related to the last. So let's do another Laplace transform problem. So in this case, where we have multiple things at the bottom, we have to do the partial fractions. So in order to do that, we take whatever we have in the bottom and distribute it. So it will be a over s minus 1 plus b over s plus 3. And then we take the common denominator. So s minus 1 times s plus 3, it will be a times s plus 3 plus b times s minus 1, and our left hand side. So now we know that our we have same thing in the bottom on the both sides, so we can multiply it with s minus 1, s plus 3 on the both sides. So we can multiply this with s minus 1 and s plus 3 on the both sides. So we can get rid of whatever we have in the denominator. So our final thing is s plus 11 equal to a s plus 3 plus b s minus 1. So further solving it, we'll get a s plus a 3a plus 3a plus b s minus 1b. So since we have s on the left hand side, we can say that it's equal to a s plus bs. We take the s's together, so s equal to a plus b whole square whole brackets and then s, and we can get rid of the s. It is 1 equal to a plus b. And we can do similar thing with 11 equal to 3a minus 1b. So We can solve for a and b since we have two equations and two unknowns. So b's cancels out and we have 12 equal to 4a. So a is equal to 3 and we can input the value of a into our first equation, which was 1 equal to a plus b, and we get 1 equal to 3 plus b, and our final b is -2. So we have a and b now. So we can write that f of s equal to, so we plug in the values of a and b into our original equation, which was a over s minus 1 plus b over s plus 3. So it will be a is 3 over s minus 1 plus b over s plus 3. And now we can use the Laplace table. So using the property that we learned about Laplace, the linearity, we can distribute the Laplace. So it will be 3 over s minus 1 plus, sorry, the inverse of Laplace, since we're doing the inverse of Laplace. And our b was -2, so we can replace the b with -2. So -2 s plus 3. So here we can take out the constants from both equations out. So it will be 3 inverse of 1 over s minus 1 plus inverse, we can take out the -2 here. So it will be plus -2 inverse Laplace of 1 over s plus 3. So looking at our given the first part and looking at our table, we can see that it's 1 over s minus 1. So we can see the second point here. So it's 1 over s minus a. So our a should be 1 in order to get that. So it's 3 times 1 over s minus 1 plus -2. So if you're looking at our table again, we know that we're still using the second point, which is 1 over s minus a. So in this case, our a is -3 in order to get s plus 3. So it should be -2 inverse of, so 1 over s minus 3. So we got our a's, and now we can go backwards. So looking at the second point, we know that it has to be e raised to power at. So we have our a's here, and we can go backwards to solve for e raised to power at. So for the first part, it would be 3 times e raised to power a is 1t minus 2 e raised to power, so our a for the second part is -3, so e raised to power -3t. So this will be our final answer. This is how we do inverse Laplace. So yeah, these are the examples using the Laplace table. Thank you for watching. Hope you liked it, and good luck for your course.